We can now eliminate the stringy chips that cause annoying machining issues with Mazak's bar in, bar out cutting toolpath. Using the new patterns 3 and 4, you can break the chip, eliminating the continuous chip from wrapping around the part. Another feature we're going to explore is the number 2 pattern on the OD operation, which was previously only available on the bar in operation. This will leave you with a more rigid part as diameters get smaller on the roughing operation. We're going to explore all this in today's Mazak Minute. Stay tuned. Hi, welcome to the Mazak Minute. I'm Mike Zillich, part of the HEH technical team. Today's topic, we're going to talk about bar in, bar out. Mazak has come out with some new patterns and a couple new features in it that I'd like to discuss with you today. Let's get started. Looking at the control types, this is good for the smooth EZ, G, X, and AI control. A bar out operation is going to be used for the inside, outside, face, and back operations. If you look at the screen, you can see you have part. You're going to see that there's 2 outs. You have one that's not highlighted and the other one that's highlighted in a magenta box. We'll talk about what the differences are here in a few minutes, but the other 2 that we have is in in a box, face in a box, back in a box. Moving over to the right on the blue part of the screen, you'll see that there is a CPT-X, CPT-Z. That's for cutting point X and Z. When the tool comes down to the part, where is it going to start cutting? I like to refer to it as contact point, and you'll see a few pictures later on in the slide here that I'll show where those points are exactly. Finally, you got finish point X and Z. In the past, we used to only have at the top in the common unit where you had to set for the entire program. Now what they give us the ability to do is control it per unit of operation. Going into a little bit of the detail of the out in a box, in a box, you're going to see that the ones that are not highlighted start from the front face of the part and machine inward. The other 2 that are highlighted in the box, they will start in the middle of the part. If you had a groove or a recess in the back that you didn't want to turn the section up in the very front of the part, we can choose those. So looking at it, next slide, you can see just what I was talking about. You have from the very front, you see that we're machining and getting our profile. Same thing as well as the inside. Over on the right side, you see the highlighted boxes. You're going to have start in the middle of the part, and you can see where the tool path will come down and it will machine, as well as on the inside, machine in the middle. The difference, a lot of times people think that there's no difference, but on the ones on the left side, it doesn't think that there's any material in the way as the approach as it cuts into the part. Whereas with the ramp angle or the relief of the insert, there will be like a 3-degree relief so that it will not rub on the back edge of the tool cutting down. Contact point, we're going to go ahead, and again, Mazak calls it cutting point. It is going to be, if you look at the screen, you see the green shaded area of with the red arrow. If I'm machining on the out, you see it starting from the outmost large diameter and the front face of the part. If I'm doing an in, it's going to be the smallest diameter and the front face of the part. The image down at the bottom of the screen with the highlighted out box, you're seeing that it's starting middle of the part, and that's where the contact point is. So that contact point, if that were 1 inch starting back further, that contact point Z would be 1.0. Again, on the inside, starting mid-range, it would still be inside the part. Description 3, finish X, finish Z. This is going to be the amount of stock that you're going to leave for the finish tool to take off. The roughing tool will rough down to a certain dimension. A lot of times people will leave at least twice the tool nose radius. That way it will take the chip breaker on the finish tool will work. In the example you see in the red, I show finish X, enter 0.032. If you want to leave 16 thousandths for a 64 or 1/64th tool nose radius. Normally, finish Z, customers will leave anywhere from 3 to 5 thousandths. If anybody's ever been to a Mazak training class or training class at our facility, you're going to notice this part should look familiar. It's the very first part that we do in the class, getting customers familiar with the programming. And going through the next items, once we answered the blue segment of what the operation is, we're going to come down to the sequence data. The sequence data will contain the rough tool and finish tool, as well as the types of patterns we want to do, cutting speeds and surface feet and feed rate, and M code for where we can give it the coolant. So as you look at the screen at the top, you can see number 1 is going to be nominal tool name, tool ID code, priority number, cutting pattern, max depth of cut, cutting speed, feed rate, M codes. The one thing I would suggest that you don't do is put an op stop at the M codes in this section. The M codes are activated at the beginning of the operation, not at the end of the operation. And finally, you're going to see number 8, finish allowance. This allows me to leave grind stock here for if I had a grinder, and instead of me having to program and trig out all the numbers of how much stock I want to leave, I can just put the values there. A lot of times people might leave 10 thousandths maybe in the X and maybe a couple thousandths in the Z. Going into the details of those descriptions of the sequence data, the nominal tool name can be a maximum of 3 digits to the left of the decimal point and 2 places to the right of the decimal. I typically will use the nomenclature of the angle of the insert. So for the 80 degrees is for CNMG insert, 55 for a DNMG insert, 35 for a VNMG insert. Then you go to tool ID code. That's how I can distinguish between what tools are in what turret station pocket numbers. If I had 2 80-degree tools, I could use a ID suffix letter to tell which one I want to use. A lot of times what I'll do is I'll use A and C for the head 1 or the left spindle, and I'll use B and D for the second spindle or the right spindle. I always like to use the B for back, that way it keeps people can always relate to it easily. Priority numbers, you're going to see that priority numbers are similar to how Mazak had it set up on their milling control. In past, people would go to a priority page on the older lathes. Now we actually follow suit as the mills, and we're going to set the priority numbers in the program. But I typically will do that at the end of the program, and I'll do that in the program layout screen. The next topic, which is the main one that I'd like to talk about, is going to be the cutting patterns. In the past, Mazak has had 0, 1, and 2. And with the smooth control, they've added 3 and 4. The one other item that they've done is the number 2 operation was for only boring bar tools. They've now added that for the OD operations as well, and we'll talk about that shortly. Pattern descriptions, okay? If those if you're new to the Mazak, you're going to see that a pound zero is what I call, on the roughing pass, will overlap between the two passes. If you look here to the left, you see that there you get a straight line up the x-axis, giving you the overlap over a clean face. A number one operation, you'll see that it will retract off at each pass at a 45 degree. I like to go with the number zero. That way my finish tool has a consistent amount of stock to take off. A number two operation. This is where I just told you guys earlier that we've added the OD. So what we can actually do now is we can turn a certain distance back, and on the OD, you can see in the screen there, it is parameter TC155. On the IDs, it's TC54. I will set these in the TPC per unit. That way I have control over each operation that I do. In the past, we had it just on the number two operation, or for the ID, and basically what it was is if you had a boring bar tool that was going very deep, and what I could do is I could open it up to the rough contour and then step it in, allowing the chips a means of evacuating out of the part. The outside, if you're doing a long part, now it's going to have a little bit more strength because the bar is the large diameter and I'm working it back closer. So if you have a very thin, small diameter, long part, it's a good operation to use with that number two. Number three and number four, this is where we can now thin the chip at a certain distance. In the previous controls, you always had to play with your feed rate to get your chip breaker to work. I'm sure there's several of you out there that have had the chips wrap around the tool, wrap around the part, wrap around the jaws, and just start flinging. This is a really nice operation that it will actually turn a certain distance in the rough operation and then dwell for a couple revolutions. Those revolutions, or the number of revolutions, is set in parameter TC71. And again, I'll set that in the TPC. Later on, after we get through the description here, I'm going to walk you through the screen at the control. That way you can see it firsthand. Finally, you got number four, which is identical to that number three, other than, which is the chip thinning. But this one mimics the number one, where you see the retract is coming off at an angle between each pass. The depth of cut, that's going to be the maximum radial depth of cut you want to take per pass on the rough operation. Depth 2, you're going to see, is going to be a diamond if you have 0, 1, 2. But when you select patterns 3 and 4, it becomes the distance that you want to cut for that dwell of TC71. Cutting speed is going to be in surface feet, or if your machine's in metric, surface meters. And feed rate, inches per revolution, millimeter per revolution. And then your M code inputs, where I typically will do the coolant commands. Again, I wouldn't use op stop there because it happens at the beginning of the operation. The next item, which is in the finish operation, or the finish tool, you're going to see down below here, you'll see that in the unit number 2, the finish tool, which is the second sequence, you'll have, just before the cutting speed, you'll have finish X, finish Z. That's where, again, I'll put the amount of stock that I want to leave for grind stock. A little view of the program. You're going to see that the part that we had up on the part print, the unit 0 is my common unit where I define the material, OD max, ID min, the length of the part, and the amount of stock that we're going to face off. Facing operation is going to be the two tools that I have. You see that I have rough 80 degree A, and then finish general out 55A. And then unit number 2, bar out, which is going to be doing the turning. And you're going to see that right now I have the pattern set to a 0 in the rough pass. The depth of cut is going to be 134 thousandths, and I got my cutting speeds and feed rates over to the right. Below that in the green is where you will define the figure pattern. So if you look at what I did is I did a tool path on some of these, and I figured I'd have a nice picture here to explain it to everybody. But that 0 is going to be where, as my tool does the rough pass, you see on the very back face how there's a overlap. It's a nice smooth cut on the face. A number 1, which is the one that comes off at an angle, if you look at that back face over here, you can see how you're getting the angle coming off instead of overlapping. A number 2, this is an OD cut here. So you're seeing the distance of, in my example here, I set TC 155. I set that to 3/4, and I set that in the TPC. What you'll see is that as it takes a cut, it's removing the stock all the way down to the finish X allowance. Then it will come back up and move over to the left and take another pass stepping down. Again, having a rigid bar stock if it's sticking out quite a ways. A number 3 pattern in the tool path, this is where we do the chip thinning. You're going to notice that it looks very similar to my number 0 cut, but it will basically in sections dwell on that rough cut, but the tool path you will not see it dwell. And in the control, basically you're seeing we have the program and I have the parts. Right now you're seeing the display in the quick Mazak. Quick Mazak, if you look at the right next to the TPC up here, if I click that icon, I can switch between a full screen of the program or have it where I can see the part shape. Having a 3D part shape is nice that as you create the program, you can see what you have machined or if you defined your part properly. What I just did here over here is on the right side of the screen, you see this orange icon. There are going to be soft keys on the side of the control, and I'm just going to come over here and I'm going to choose the ZX plane, and I'm going to fit that to the screen so we can see a little bit what's going on. If I come down here and I select each of the operations, you'll see a little area of where it's removing the material. And I'm going to scroll down to the bar out, which we're talking about with the topic here. And you see that there is a bar out contact point of the material, 5 inches. Because I faced the part already, you're seeing contact point Z of 0, finish X 32 thousandths, finish Z 3 thousandths. The tool descriptions, general out 80A. And here you're seeing a priority number 1. The patterns, and I'm going to go ahead and change this pattern here. I'm going to come down and hit program edit. I'm going to change that to a 0. Okay, that's going to give me that nice overlap on the screen. My figure pattern, you're going to start from the smallest diameter from the front face, working my way in, so you got a line. I put a chamfer of 20 thousandths on it, and then a 2-inch diameter, 1.75 back. When you come down to the taper, there is, when you're on the start point, there is a soft key called next, and that if you hit next, it will give you the previous point of the previous line. So you see how you got the 2 and the 1.75, and then I just had to enter in the 4 and the 3.75. And then finally the last segment was a line, 4-inch, 4.75 back. We have the end statement there, returning to the tool change position which that tool change position is handled by parameter SU10. So if I hit my far right key, we're going to come over here to Program Complete, and I'm going to go to Toolpath. When I do toolpath myself, I like to, we can look at it in two different views. You can view it in a solid model, which if I come back over here, I fit the screen, and I'm going to zoom in, I'm going to roll my mouse, or if you do your fingers, you can, like an iPhone, you can bring the control into where you want. And I'm going to go ahead and do path step. You get your facing operation, and right away it went to the rough operation, because of the priority numbers in the rough tool. I had 1 and 1 for the face and for the bar out. Anytime you want to, and you can hit the path erase, but if you notice here, you'll see that that 0, I'm getting that overlap. If I want to, then I can go path continue and let it finish. The next one we're going to do is I'm going to go back to the program, and we're going to make a program edit. I'm going to go into program edit mode. We're going to come down to the pattern, and I'm going to select the number 1 pattern. Number 1 pattern, if you recall, the distance, or I'm sorry, a number 1 pattern is going to be where it comes off at an angle. So if I come down here and I'm going to say Program Complete, Toolpath, and this time I'm going to switch it over to the wireframe. I'm going to come up to the top left of the screen. You're going to see an icon with a toolpath, and that switches it over to the wireframe. I'm going to hit Part Shape. And now what I'm going to do is I'm going to show you how to restart a toolpath. I don't have to run the toolpath from the very beginning. So I can hit the very right arrow, Path Restart, and I can come down and choose, in this case I'm going to choose the bar out rough. Hit the far right arrow key one more time, and now I can go to Path Step, and it goes right into cutting the material on the OD. Notice again, you're seeing it come off at an angle. That's what the number 1 operation does. Back to the program, I'm going to go ahead and do a program edit. And this time we're going to go ahead and I'm going to change the bar out statement to a pattern of number 2. Number 2 has the TC155 in the parameters, and I'm going to go to the TPC so I can show you that. So I'm going to come up to the top of my screen, and you're going to see next to the question mark, to the left of the question mark, is a cutting tool with a path. I'm going to click on that, and you're going to see it's going to show me the parameters that are related to this operation. If I scroll down, you're going to come down here and you're going to see TC155, the outer cutting divide cut width. I selected 3/4. You can select whichever best suits you for your material. Obviously, based on the different material types, you'll be able to cut further or less. I'm going to go ahead and hit End, and you're going to see a plus sign here. That plus sign next to the unit number, that's going to tell you that there is a TPC set with that unit. And when you save the program, that gets saved along with the program, that TPC. Let's go look at a toolpath now. I'm going to come over here, far right key, Program Complete, Toolpath. I'm going to stay again in the wireframe. That's my preference. And you see the parts. I'm going to come over here. We're going to do a path restart. And I'm going to go ahead and choose that bar out. We'll say OK. Far right arrow key, path step. And what you're going to notice now is it is cutting down 3/4 back. Again, a nice way to control if you had a long part that had a small turn diameter at the very front. It gives you some rigidity in the bar. You're using that until the very last point where you need to turn just with the finish tool. Number 3 operation. Okay, again, this, like I told you, this is going to be, if you look down here at your soft keys, that looks very close to the 0 and 1. But you notice that the 0 and 1, or excuse me, 0 and 3 are the ones that do the overlap. But the number 3, you can see how there's like a little line there, like it pauses. A number 4 looks like the number 1, and you're seeing how it comes off at an angle, and you see the pause. Where do you set the pause? You're going to come here. I'm going to move my prompt. And for those of you, as you're seeing that this prompt has been moving around on me, you can move it to a certain point on your screen, and there's a pin. If I hit that pin on that screen, that will leave it there. So if I go ahead and I'm going to make the pattern a number 3 this time, so that we can see how to do the chip thinning. I'm going to come here and I'm going to click on the pattern, select number 3, and what you're going to notice when I select number 3, to the right of the depth 1 on the roughing tool, you see how I have a diamond there right now? When I hit 3, you see that becomes available. I can now cursor over there and I can enter in a distance of how far I want to rough before I go into the chip thinning operation. So if I wanted to say 1 inch or 1/2 inch, 1/4 inch, whatever you need, you can put that value right there. Now the number of dwells of the revolution is going to be in the TPC. So again, I'm going to come back up to the top of the screen where the TPC is, next to the question mark. I'm going to press that, and you're going to see that TC71. I'm going to go ahead and highlight it here. You see the default is set to a 0. I'm going to go ahead and maybe set that to a 2. I'm going to dwell for 2 revolutions. So in all honesty, you're not going to see really that cutter slow down, but it's going to be dwelling for 2 revolutions, just enough to thin that chip to break it. I'm going to go ahead and hit TPC end, and you see the plus sign there. I'm going to hit the far right arrow key, program complete. And then we're going to go do the tool path, part shape, and do the path restart. And this time we're going to do it on the bar out again. Path step. So it's going to look just like a number 1 operation, but if you're at the machine, you're going to get a dwell in there giving you the chip break. The number 4 operation, where it's going to be the pull off, it's going to look pretty much identical, other than you're going to see the coming off there. Thanks for watching this Mazak Minute on bar in, bar out, the new features and enhancements that Mazak has given us with the smooth control. What I'd like to see, if you guys could, leave me a comment on the bottom of the screen. I'd like to see what topics you'd like me to cover in future Mazak Minute episodes. Thank you. Have a good one.